Hey gang, welcome back to Inverted Pursuits Laboratory, and this week we're going to be working on the EggTimer RX. So this is a little unit designed specifically for transmitting your EggTimer data onto a PC or even over Bluetooth on your phone, instead of having to go to an EggTimer base station LCD screen. So just a different option for a way that you can get the data from your tracking devices or your flight computers. So let's take a look at how it's built. Alright, so as we dig into our parts, first thing we're going to have is a parts list. Let me flatten this out a little more. This parts list is really what I recommend you use to verify everything you've got. Not the easiest to read. Everything you need down. So we'll set this off to the side and do a quick look at what we've got. So one thing we have is solder. This is actually some leftover solder from a previous project. Fresh stuff comes in a very nice bag. It's very nice to see. We'll also have there's the brass antenna is in this tube of heat shrink. That's what I get for trying to keep it safe, but it's in here. I actually won't be using this. I really don't like these brass antennas. I've never been able to get them to work. I know some people swear up and down by them, and that's great. I know they work for some. I can never get these brass antennas to work. So I'm actually going to take this and set it to the side. And for the purpose of this build, I bought an extra RPSMA connector, and we'll be using this in conjunction with one of the antennas from EggTimer. So, and for those not familiar with their antennas, it's the same one that comes with the EggTimer tracker when you buy their whole enchilada pack. It's just a standard black antenna. You can replace these with other forms of antennas. So you also have, for the USB version, you'll have a USB serial cable if you buy that. It also comes with one zip tie. Or for the Bluetooth version, you get a Bluetooth module and a 4-pin cable. So I bought the Bluetooth module in case I want to try that instead of doing the cable. I'm initially going to probably set this up to work with a tablet, so I'm going to try the Bluetooth as my primary means of connection, but this cable will be a really handy way of checking it in the field on a laptop. So I'll set those off to the side. Then inside our main bag of parts, we've got our Hope RF module right here, which is really nice to see. I'm going to leave it in there for the moment, and then I'm going to get the parts specifically for the build out, and we'll go through all of those. And there aren't a lot of parts, which is really nice. So we've got our base circuit board that we'll be working off of. We've got a 8-pin header, a 3-pin header, and that is all blurry, so let's actually get you guys in a little closer to make this easier to see. Apologies. You will have an LED red. So sometimes their red LEDs aren't actually red cased, they'll be clear, but this one is actually red. And we've got our voltage regulator, which is this little guy here. It's a 3.3 volt voltage regulator. Then we've got a 2.2 kilo ohm resistor. I also called them the 222s. Let's see if I can get those in focus so you can see. They say 222 on them. Alright, it's not one to pull in, but they say 222 on them. They're the only black resistors in paper tape. We have a jumper, and then we have a 10 microfarad capacitor, which is the brown and clear packaging. So there aren't a whole lot of parts to this build, and that's actually going to make this go really fast. So the first thing they have us do, and we'll get this kind of resituated here, pull our parts off to the side. I tend to organize my parts into these little squares I've got on the table. I just set one in each square off to the side just to keep track of them. I just tend to be a little overprotective of all my parts. So the first thing we're going to be doing is the voltage regulator. The voltage regulator goes right here. This is the top of our board. and this is the bottom of our board. So we'll install the voltage regulator right here. First thing I want to do is verify my soldering iron is actually working correctly. So I've had it heating up for the last little bit, and I'll bring it on screen here to show you. So I'm just tinning the tip of it real quick, and then stabbing it in my steel wool to like make sure I've got a really nice clean tip. So then we're going to start with the big pad. You always start with the big pad on these EggTimers. Get a good chunk on there. And then I should have gone ahead and opened up the voltage regulator packaging already. So let me get that open real quick. Drop the voltage regulator out. Alright, so the way we're actually going to do this, I'm going to turn the board sideways, make this a little easier on myself. I'll be holding the voltage regulator with my left hand, holding soldering iron with my right hand, and we're going to heat up the pad and the tab kind of all at once. Try and get this on here. It's playing really nicely. Okay, and now you can see we got the solder to pull over the top of the tab, and that's exactly what we wanted to see. And so then we will right this back up. I'll bring the solder in, and we are going to solder the bottom 3 fingers on this real quick. And I'm doing this from left to right. Doesn't really matter if you do it right to left or left to right. That's just where I like to start. All right. Next, we mount our 2 10 microfarad capacitors. They mount right around the outside here. They're both labeled 10 microfarads. So I'm gonna tin that pad, and then I'm actually gonna tin the top pad on this one. Be careful you don't accidentally touch the voltage regulator with your soldering iron. That will mess up a lot of things as you're going. Try and get this pick and place packaging open. So, nice thing, the capacitors are not polarized, so it does not matter which one goes where, what direction is up or down, and there's no positive or negative terminals. So my initial goal is just to get this to stick on here. Alright, like that. That's what I wanted. We're going to turn it 90 degrees real quick, and I'm going to stick the other one on here before I solder their back sides on. So, just going for getting them aligned. That is well adhered. And I'm going to come in here from the side. My goal is to heat up the pad and the capacitor all at once. Get a good little blob going. Call it good. I'm going to flip it over. Be sure you turn the board to make it easy to work on for yourself. I sometimes don't do that when I'm working with you guys, and it's not always bit me, but you've probably seen a few videos where that has bit me. Try and not wobble it too much. So we can see our 2 10 microfarad capacitors are now installed. And it looks like it's focused, but I really can't tell. Let's try and bring this in a little closer. That's a lot better. Alright. Sorry guys for some of this not always being perfectly in focus. We do this with what we have. Next thing we're mounting is our 222 resistor. We're given 2 of these 222 resistors. Looks like we only need 1 based on what is shown on the board. That is not uncommon. Resistors are thankfully cheap enough. They often will give us spares. These resistors are also super tiny. I always mount the resistors so that the text on, or the printing on the board and the printing on the resistor read the exact same direction. So for you guys, that reads left to right on your screen. So let's get this pad soldered up. Whew. Bumping the camera there a little bit. Sorry about that, guys. I am trying to get a hold of my resistor. Alright. Now these resistors are not polarized. It does not change the fact that I like to do them a certain way. So alrighty, there's our 222 mounted. Now the next thing we're supposed to mount is the Hope RF module. This thing is extremely fragile. I will say that as many times as I need to. The Hope RF module here is extremely fragile. Oh, I guess, I'm sorry, we're not onto the Hope RF module yet. I missed a part. My bad. Alright, so we're gonna set that off to the side again. We actually need to mount the red LED. As a reminder, with LEDs, the long pole is the positive pole, the short pole is the negative. There's a positive marking on this side, so positive goes to long, short goes to negative. What I do is I put these through here, and then I grab the wires and I bend them out, and then I'm gonna flip it over and tack them in real quick before I then cut them off. Alrighty. Now we need to nip those off real quick. I did forget my nippers, so let me go grab those. Make sure I keep them ready to go. And so we'll come in here and just give that a quick clip. Thankfully we don't need these nippers. Currently don't need these clippers for any other part of the build. I think we'll actually need them for cutting apart some of the multi-pin connectors. But now the next step is to mount that Hope RF module. The Hope RF module mounts best using a piece of tape to assist you in attaching it. So usually they recommend a 2-inch long piece of tape. I usually run about a 4-inch long piece of tape, about ½ an inch wide. That is what I've determined to be the most effective, and so that looks about like that. So what I'll do is get the Hope RF module on here, get it lined up, or reasonably lined up, and then I will use the tape to hold it down. So I just tape across the module, helping line it up with the tape, and then I tape it down to the table. Now the Hope RF module, I've done dozens of these in various videos. You'll want to solder one pin, and then usually the idea is to kind of like roughly realign it from that one pin, and then go ahead and do each one. You need to wait 30 seconds between each pin as you go across. There are 1, 2, 3, 4, 5. Let's try to count that again. 1, 2, 3, 4, 5, 6, 7 on the bottom and 2 on the top. When you're soldering them, I'll give you a real quick example. Your goal is to put about that much solder on it. They've got images on their instructions that show what that looks like. It is literally just enough to bridge between the pad and the top of this thing. You do not want to fill the hole on the Hope RF module. Now I have done that on units, filled the hole. That's about how my Quasar went. It was a little rough to put together, but that's how we ended up doing the whole thing. but we'll go ahead and get this put together, and then we'll get back to this. So that's our last pad. Now, if I'd wanted to put the stick antenna on, which I am not going to do, filling this hole in would be basically my worst nightmare. That would have really screwed me up. But since we are going to be using the RPSMA connector right here, I am not completely dead in the water. And I got lucky, I didn't get any solder any further down, so I'm going to be able to get in here really easily and solder these pads on. Now, it's also recommended that while we're soldering these pads, we wait 30 seconds between soldering operations, maybe a little longer. Also, note that the RPSMA connector is about to get really hot. Like, this thing is going to absorb a lot of heat, as will the board pad, and it is not going to exactly be pleasant to touch if you accidentally bump it. So we'll wait 30 seconds here. Now that we've got that first pad on, I am going to go ahead and reorient this thing. I don't need it taped down anymore. And yeah, that's hot, so be careful. I'm going to flip it over to make it easier to get my soldering iron in here. That is really our main goal, is to make sure things are easy to work on. Alright, done 30 seconds. I'm going to go with the antenna wire this time. Now, I want to be very careful about coming in over the Hope RF module. Make sure I get plenty of solder on that. And we'll wait 30 seconds again. Now, ooh, didn't mean to do that, guys. Sorry about that. Now, I will point out, there is one big thing that is not ever included in these kits, and that is power cables. So you need to figure out what you want to power this off of. Power requirements vary pretty drastically on some of these boards. For the most part, I've been able to run them off 1 and 2 cell, or 1 and 2S LiPos, and that's been kind of my favorite way of running them, is to just have the LiPos to run them on. Reflow all that. Alright, so now we've done one side. That's one side of the board. We actually want to flip over and go ahead and solder both these tabs onto the back as well. That helps provide some structure to the antenna being mounted on here. Even though this isn't ever going to be in flight, it's just a really good practice to always go ahead and do those. So we'll get in here real quick. Alright, get a nice smooth look on there. Wait another 30 seconds. Didn't quite wait 30 seconds on that one, but you really want to. Alright, now we'll come in here and get our last one done. I need to re-clean that tip, get better heat transfer. There we go, got great heat transfer between all of those. Alright, there we go. Now comes the headers. So we already have one 3-pin header and we've got an 8-pin header. That 8-pin header needs to be cut into a 4, a 2, and a 1 from the looks of this. So I'm gonna go ahead and flip this back over. So we've got a 3-pin header. I'll go ahead and cut a 4-pin header out of this. That's my 4-pin header. Alright, 4-pin header. Now we need a 2 and a 1. I've now got 2 4-pins, so there's my 2-pin. And then I'll cut this one in half again. And I end up with 2 1-pin headers So there's the one I need, and set the other one off to the side. Or, unfortunately in my case, it went flying across the room. I will have to find that later. So, now we've got two different things we're going to do here. If you want to build the version that uses the USB cable, we mount them on the top of the board. If you're building the version that uses the Bluetooth and is going to be mounted in the case, you mount the pins, the headers, to the bottom of the board down here. Since predominantly I'm expecting to have this mounted in a case on the bottom of the case, not on the top of the case, just the way I put this together, I'm going to go ahead and put all my pins on the top. It's just kind of my general use case for a board. And we'll orient the board like this, because it will make it easiest to solder, in my opinion. Actually, orientation won't matter, because we're going to have to flip this over anyway. So, short side goes in the board, long side is your header to stick up. I'll put our 3-pin in there. Our 1. Oh my goodness. So I bump the camera. I really need to fix the camera. 4. Now, if we take our piece of tape that we used earlier, and I go across them all, I should be able to kind of force them back down in. We can see from this side that I've got them all in there. Squareness is something you do want to pay attention to. Try and get them spaced nicely. I am really struggling with that. With this many, trying to do them all at once. I may just end up wanting to do these all individually. Alright, I'm able to get them all lined up and spaced pretty nicely, and I can flip them over on the board. Oh my god, I cannot stop bumping that. And we can see all of the pins right there. It's not as supported as I would like it to be, so what I'm actually going to do, I'm going to take the head of my USB cable, slide it under the board, and that levels the board out really nicely. So my first goal is to tack down a minimum of 1 pin on every single header. So we're going to go ahead and come in here, tack that one down, tack, that didn't go well, tack that one down, and we'll tack that one down. And we'll also go ahead and tack our 1 pin header in place. Now we want to go ahead and take the tape off and flip it over. Check how square our pin headers are, which those are not the world's greatest, but honestly I've done way worse on flight ready hardware. Go ahead and pull my mat back. So we're going to go ahead and flip it back over and solder them all in place, because I actually like those the way they are. So come in and get the remainder of our 3-pin header. I am oxidizing really fast on this tip, so that is going to be its own interesting issue. My tip is not wanting to stay tinned, so it is making soldering a royal pain in the butt. For those that may not be aware, the 2-pin header we just soldered is actually our programming header. And so what we'll do with that is we'll short across it with the jumper they gave us to create a short and put the system, or put the board into programming mode. That'll allow us to set the ID of the board. So like it comes on the standard frequency 915 channel 0. There are 7 channels per. If I remember correctly, I usually run in the 921 band personally, but that is every inch of the board put together. Aside from power, should have actually done some of this a little differently. So if I want to use the USB cable, USB is actually providing power on my black and red lines. Green would be unused, so I'd actually solder black and red to my power. Green is my clock one here, and black and red are my power. If you are going to be using the Bluetooth option, there is an insert picture here. That is on every single instruction. So this is actually something why I actually haven't implemented Bluetooth, and I was really wanting to on this project. We're kind of going to see how that ends up going. There's just a spot that says insert picture here on all of the EggTimer Bluetooth instructions. I'll do a little more digging, see if I can actually figure this out. But EggTimer, dude, if you're watching, you really need to update those instructions to not just say insert picture here. It kind of makes this a little confusing. I am 90% certain the fact that this says BT06 on here, and this is a BT06 module. That kind of tells me how it's supposed to go together. So I'm actually going to hook this up the way I would argue it hooks up. So on here I have got, let me make sure this is in focus. Alright, I've got RTX, TX, ground, and VCC. So green is my RTX, blue my TX, brown is ground, gray is my high voltage. So the way I'm actually going to do this is basically the same thing exists over here. RTX, TDX, ground, and 3V3 volt on this. So line up my silver with the 3.3 volt line and connect them. I am 90% certain that is how the Bluetooth is supposed to connect. It's the only thing that makes sense as far as like mounting these together. But again, there are no clear instructions on how to properly mount the Bluetooth module. That's just been my best understanding. So another interesting thing is you will actually require a functional EggTimer transmitter to get this fully set up. So that means having a fully functioning EggTimer LCD, which I thankfully have, because you need to hook up power to this thing and actually test it. So give me a second to get my egg finder hooked up, and then I will give you guys a quick walkthrough on how I do the programming of this system. Go. Alright, so I've got my ultimate egg finder tracker box here. This thing is way overbuilt, but I've got my 3-pin coming out of here. Everything is turned off. It's got the power connected there. I am going to be passing power to my transmitter. I want to make sure I've got an antenna on this before I turn it on. It's never a good idea to turn on like transmitter without a load. The other thing I want to do is I want to take this 2-pin jumper and I'm going to put it on the programming cable here. I also do not want my Bluetooth plugged in, so I'm going to unplug the Bluetooth module and set it off to the side. From there, we're going to try and match these up. So I have this coming out the top, and some of you may remember from my left to right here, it'll be your right to left. It's positive ground. RX, TX stuff. So for me on here, this 3-pin header, my TX is on the left hand side, 3v3 is on the right hand side, so I'm actually going to take this and plug it in upside down like that, and then we will power on our egg finder tracker. So now we got all the boards come on. programming mode. I want frequency/ID, both menus. Receiver config. Frequency/ID is what we're going with. I'm gonna jump into frequency. I want 921. ID 7, yep. So then we turn it off. Alright, so now I should be able to power this off. Initially here, I am not wanting to use this like with, I guess initially I'm going to be using this with the USB dongle. I'm hoping to be able to use it with the Bluetooth module more, but that means I need separate power for this. So if you're wanting to power it, oh man, it really wants to be powered off a battery box. So on that note, I'm actually going to go ahead and make sure I always power it off USB. That's mostly a safety thing at this point than anything else. I want to go ahead and power this entirely off of USB. So we're gonna, oh, I've got two, I've stripped the black and red from here. I'm gonna go ahead and leave the white connected. I know in the instructions they show to like strip the white and clip the green. I probably, you know, I should clip the green off, otherwise I will forget which one goes where. So green is getting clipped because we don't need it at all. Get removed. Move our positive and negative wires. So again, red is positive, black is negative. We're gonna go ahead and I'm just gonna plug in the white one to get it out of my way. Put the negative lead through the negative hole. Positive lead set through the positive hole. So try and leave that obviously visible to you guys. I know we've kind of changed camera setups here, but I promise you it is not that big of a change. Alright, let's add a little heat over here. Just put a little more on the negative side pad. Get a bit more to work its way through. That's a better looking pad on the back side. Alright. So we end up with that connection setup, and this will allow us to plug it into our PC and do testing with the PC. And then you'll want to download Visual GPS or Hyperterminal. Visual GPS is definitely the better program. Let's see if we can get this to work. So we've got our unit here. I have got a TX, actually the Quasar, plugged in and transmitting. So we're going to actually plug into the computer over here, and we see we get lights. I forgot to undo the programming cable. Gosh darn it. So I take the programming pin off. Do not forget to do that. It will not run with the programming pin on. Alright, so that's roughly what that's supposed to do, from what I understand. Sorry, on here, red indicator is just for power. So this blinking means we're receiving data, which is good. Okay, I've been told that will just automatically connect. Sorry. So I'm hoping to get like longitude and latitude data to show up here. Alright, so now we have got data. So this is data streaming from our quasar. I'll bring that on screen here. This is a quasar inside a, this is the updated sled that was designed specifically for the quasar that goes inside my screwball. Also is going to go inside an upcoming rocket design I'm getting ready to test and release. But this is all designed for the quasar and other EggTimer products in mind to mount inside the screwball rocket. So this is our quasar, and it's running happily, transmitting data, and is powered off a little 2S LiPo back here. So the quasar is sitting here transmitting data. We can see satellites that I'm able to view currently on the grid. So I've got 7 satellites I'm pulling from. Satellites in view, 4 or 5 are tracked right now. I've got VDOP, HDOP, PDOP, I have no clue what those are. My altitude, it's telling me in meters. Latitude, longitude, those are pretty handy. Let's see if we got a scatter plot of, I guess, where it thinks I am versus where it thinks the GPS is, which actually that might be pretty accurate. I think the yellow thing is my GPS, is my unit, and green is base station. I don't actually have a way of proving that. Yeah. Gives me a position plot, kind of how things have been moving around, how we're moving. And then this is all the data that we're receiving on the NEMA monitor. The scatter plot's definitely interesting. I wish I knew more about what the green and yellow it was showing me is. But this is the front panel here, and we can just see the strength from the different GPS satellites I'm seeing in the area. So I've got 8 satellites in view and 7 satellites tracked. I should also note that we are in the basement right now, and like the quasar is solidly tracking satellites down here, no problem. So I've had issues with it before being in the basement. I've had issues before without like putting the run system on the GPS. But so these are some things we're able to currently see. My goal is I'm going to do a little bit of work off screen, and then we'll come back on here, and well, it'll be just a moment for you guys, maybe a day or two for me. I want to try and get a full map running to plot this data to, and so that we'll actually be able to see a nice like where everything is. I'm pretty sure green is me and yellow is what I'm tracking, but I still need to figure that out. Alright, we're going to do this quickly as I can because the battery's starting to die. So, I hooked up my Bluetooth module here, and I was saying I was wanting to get this working on a pretty map. I remembered that the Missile Work system uses a program called Rocket Locator on Android devices. So I've currently got this plugged in, data is disconnected to a PC, so I'm just using the PC for power. I'm transmitting via my Bluetooth device, and it is actually transmitting to my phone on Rocket Locator. And so you can see I'm getting my position, where it thinks I'm at, and where it thinks the quasar is at, which actually that's pretty much spot on where the quasar is at in my house. But what I'm able to do here is actually see where we're at on a visual map, and this is going to work really well for me in the field to be able to track things. So I'm going to be able to use this with a tablet is my goal. I'll download Rocket Locator on a tablet and be able to transmit this data over to a tablet and have a visual GPS like map lookout of where things are at. Or they recommend you use the program called Bluetooth GPS on there, but it only outputs data. This Rocket Locator program is one I know worked with the missile work system, so I thought I'd figure out if it worked here. I can confirm it does work here. You have to go into settings here, hit settings, and then the Bluetooth device. Just make sure you select your BT04A, and that will be this device. So if you're looking for a way to visually track your rocket on a map, Rocket Locator paired with the RX and the Bluetooth module will be able to do it. I have not figured out a way to do it on the PC yet. Hoping to figure that out and get that added into the next section of this video, but that's a quick way to do it on your phone from Bluetooth. Alright gang, so I ran into some issues getting things going. I've been unable to get my EggTimer RX to communicate over serial on my PC. It's just throwing an error right now. I've got an email into Chris at EggTimer. We'll see when he gets back to me. I have a funny feeling he's not going to get back to me before this video gets out. So like, just know, like, Bluetooth works great, visual GPS works great on your over serial. Visual GPS works great over Bluetooth. Rocket Locator app on your phone both work great. All in all, I've not been able to get a map-based system on a laptop to work, so still working on that. Probably make a separate video all about that stuff. But I wanted to show you a case I've been working on for the EggTimer. This was going to be the first of 2 different variants, and I'll have them all linked in the description below. But this is one EggTimer case right here, and as you can see, I only have one screw in it right now, but I've got the unit mounted in here. Might actually help if I got some light on me. There we go. So you can see I've got the unit mounted in here, and it's like just pretty simply mounted in here. Data coming out, cable just comes out the bottom. I've only got one of the 4 screws in here right now, but I just usually put only 2. I usually design 4 holes, but I usually only use 2 opposite corners to hold the whole thing together. And then I designed these little hooks that you can screw on the side, and the whole purpose of those hooks is for like hooking it over your laptop real quick. So then you just plug in to your laptop and you're good to go. You've got your whole data set up. You can run around as you're like tracking your rocket with data, or if you want to, you can like even hook it on your belt real quick, have it hooked down here on your belt, like adjust your antenna out a little bit, and then still be functioning on your laptop for doing things. So there's a couple different ways this little design can be used, but I've got one more design I made up specifically to work with the Bluetooth setup. So it will have its own integrated battery and will completely remove this cable for that design. I don't really know how I'm wanting to use it right now, so mine's still probably gonna end up with the cable just shoved inside here, but that's one of the case mounts. So let's do a quick jump scan and I'll show you the other one. Alright, so we just looked at this, and as you can see, I've disassembled it because I wanted to actually get to the next part, which was building the box for Bluetooth. So this thing has an integrated 3AA battery, has a Bluetooth module, has our RX module, has a power switch located on the side, so the moment you flick that power switch on, everything whirs to life. So we can see it all works. It also comes with a handy little like lanyard mount. So the point of this, at least in my thought, is that I can, out in the field, just throw this around my neck, and then I've got my phone in my hand. Here, actually, let me get my phone out. I'll have my phone and be able to look at the Bluetooth app and look at all the different, like, oh, there's where the rocket is, and just can walk around this hanging around my neck. It also leaves accessible the clip we use a lot of the time for our name badges out at the fields. The only thing that I don't currently like with this is that the screws for the battery mount hang out the back, and I'll have a link to what battery mount I used in the listing for this box on Printables. So if you want to download this box or the box I just showed you previously, check out the link in the description below, take you to Printables, and you can look at both of these. My current recommendation is to use some super glue to hold this in because the screws aren't great. That, or try and find some shorter screws. It just didn't quite work out the way I'd hoped it would, but I'm just going to end up throwing a little bit of super glue underneath the battery mount and it'll be fine. So that is currently the design. You can kind of fold it down. It's got a lid. I should mention that. It's got a lid that slots in, so there's actually like lip retention down there, so you don't have to have a screw at the bottom. There is a spot for 2 screws. You don't have to have a screw, and then you really only need 1 screw to go on this thing to hold it all on. So you just toss your 1 screw in, and the whole thing will just stay together. When you flick it on, you'll be able to see the RX light, which will be green flashing, your power light, which will just be solid red, your Bluetooth light, which will also be solid red when you turn them all on, so you can kind of see the red glowing through there. I don't really actually know how well that's visible. I'm hoping it's visible that there's red glowing through there. It's actually a lot easier to see than I thought it would be, but the front of it has, of course, the 4.5 volt 3 AA battery label on it, so you always know exactly what this needs. You won't be questioning it. Another way to power this, if you're not wanting to power it off 3 AA batteries, is to leave your serial cable attached and then plug a power bank into it for like your phone. That'll power it just as well. I wanted to go ahead and set this up in more of a compact setup than having to plug this into a power bank. So I went ahead and did the 3 AA batteries for this design, but there are a lot of different ways you could set it up. If you really wanted to, you could figure out, we could make a modification off this if we really wanted to, put Bluetooth in it, no batteries, and then just plug the cable straight into a USB bank, and you'd still have a smaller platform. So there's a couple different ways we could look at this, but that's pretty much where we're going to end this series. If you have any questions you'd like to ask, always leave a comment in the description below. I'll figure it out and get back to you. If you're viewing this on the Rocketry forum, leave a comment here. I know Chris will get back. He watches a lot of these threads, so he's always great about getting back to you with questions you might have. But I hope this helps you. Want to have a lot more fun building the EggTimer products. I'll see you out in the fields. Hey gang, one more thing before you go. If you're interested in helping support the channel, please check out the link in the description below to our web store. On the web store, you'll find all sorts of 3D printed rocket kits and accessories, including camera shrouds, which are one of our most popular items. Everything you buy there really helps support the channel and helps us make a lot more cool items that we can make available to you guys for free on our printables page. If there's anything you find on our printables page that you'd like to have printed and you don't have a printer yourself to do the work, please use our contact page to reach out to us and we can start that discussion. Thanks for watching, gang.